Return recording. అంటే ఇప్పుడు నాకు అదే వాళ్ళకి కాపరేట్ చేస్తారంటే
సరే మీ ఇష్టం, నాకేం లేదు. కాబట్టి వాళ్ళ మధ్యలో అబ్జర్వ్ చేస్తున్నాను.
Good morning, sir.
Yeah, good morning. Good morning, everyone. Good morning. Yeah. So let me continue friction again. And see, I think the last one is, what is the last one? Can anyone remember? Last problem, what I covered? I think I calculated.
Sir, angle of friction.
Tension.
Yeah, angle of friction is covered, and maybe I did one problem. Coefficient of friction I calculated, I think. Okay.
Yes, sir.
Yeah, I hope you remember. Okay. Let us suppose they given some two blocks. They connected with a wire passing over a something frictionless pulley. How they place this? See, they place it like this. This is something 4 kg, and above some mass is placed. Above something mass is placed. Coefficient of friction here is, let us suppose 1/3. Okay, and this system connected with a pulley, and that is passing over a frictionless pulley connected with something 6 kg. Yeah, getting it. Now, what is the question here is, for what value of m, this system is ready to move? Tell me. means how much mass you have to place so that this system has to move. So write the question in a shortcut way. Instead of writing lengthy words, write a question in a shortcut way. For what value of m, for what value of m, the system ready to slide. The system ready to slide. Follow the problem. Follow the question. Everyone,
Sir.
draw the diagram. How much mass you have to place on 4 kg so that the system has to ready to move. How it will move. They given coefficient of friction between the block system and surface is mentioned 1/3. Something is given, whatever may be the value. Okay. Draw the question. Draw it. Next I'll continue some concept after this problem. Again, there is a simple logic. System is not moving. If it is moving, again the conditions are different. System ready to move. System ready to move. That's it. Just see the free body diagram concept. This is the tension, and this is balanced by how much? How much it is? 60.
Yes.
Are you following? Please
Yes,
respond.
sir.
Yeah. If this is the tension, here what is T? If it is in motion, if this system is in motion, then we can write T minus what is left side? Frictional force will act.
Yes, sir.
Yeah, frictional force will act. But what is the condition they given? For what value of m that system ready to move? This system, this block system, not this one, ready to move.
So
So
then it is FL, no sir, you have written FK.
FL only, right? Correct. FL, maximum value. Very good. Good. So when the system ready to slide, then shall I balance T, which is equivalent to FL? Is it correct? Is the condition is correct? T is equal to FL condition is correct or not?
Yes, sir. Correct.
Yeah, it's
Correct,
correct.
sir.
Yeah. How much this T? 60. FL nothing but what is FL? Mu n. What is FL? Mu n. What is this n actually? You know how to find out n value? You know how to find out n value at this point and at this point. Tell me what is the n value at here? 4 plus m into g. Above how many masses are there? 4 kg and m. So how many masses are there above this point?
One mass.
Yeah, only one mass. So this is 1/3. This is what? 4 plus m into g. What is our question? M. What is our question exactly? M. So find m. Got the answer already. Check it. So this is how much now? 60 into 3. 4 plus m into 10. So strike off the 0. 18. 4 plus m.
14.
What is m
14.
now? Yeah, 14 kg. Very huge.
Sure. Greater.
No problem. Means you have to keep that much mass so that the system is ready to move. Because 6 kg is hanging vertically. Don't expect as a here it's same mass. Because wire is connected. Yeah, completed?
Yes.
Yes, sir.
Okay. Now see, let us do some concepts. Write down some concepts on horizontal motion, means in horizontal direction. Let us suppose they given something roller, lawn roller. Here the word lawn roller, road roller, lawn roller. Okay, let us see that roller is easy to pull or easy to push, which is convenient. So write down some concepts. I can note pulling and pushing of a roller. Pulling and pushing of a lawn roller. Pushing and pulling of a lawn roller. Otherwise, roller. Let us see which is easy, whether it is pulling is easy or pushing is easy. Let us suppose this is the roller which is placed on horizontal surface. Roller mass is m. Roller mass is m. Then weight of the roller is acts
mg
vertically downwards. And what is this?
normal
Normal reaction force. Now let me try to push with some force, with some handle arrangement like that. By making something angle theta. I applied a pushing force like this. This is the pushing force. Then just resolve this force into two components. Resolve the force into two components. If this is F, what is this? F in this direction. F or not? And if this is theta, what is this?
F cos theta, sir.
Yeah, this is what? F cos theta. And what in which side F sin theta will act? Downside or upside?
Upside.
F cos theta, F is the middle. So in this direction,
Downside.
F sin theta.
Yes,
Downside or up? Down or up?
down,
Downside, sir.
Down.
Yeah, down. F sin theta. So roller is ready to move with a F cos theta force in the forward direction. Then which force it will act in the back side? Fr,
frictional force,
frictional force. If it is in motion, Fr will be there left side. What is Fr? Rolling friction.
rolling friction,
Fr is the rolling friction. First of all, let us identify how much the frictional force acting here. Frictional force, Fr, which is equivalent to mu n. Fr, mu, what is n? N is balanced by how many forces from the diagram?
mg plus f sin theta.
Yeah, very
mg
good.
plus f sin theta, sir.
mg plus f sin theta. Okay, mg plus f sin theta. Let us suppose this is equation number something 1. mg plus f sin theta. So frictional force is more. Frictional force is more. Now we can find resultant force also. Resultant force. F is equals to f cos theta minus. What is resultant force? Because the roller is moving right side. What is the net force acting on the roller? Fr. Fr is equals to f cos theta minus Fr.
Rolling friction.
Yeah, f cos theta minus Fr. If you want, just you substitute the values. You will get some more equations. Okay, the way you find it means what is frictional force? Frictional force is something I am getting positive. I am getting positive means maximum. Frictional force is maximum. Okay, and this is the net force. For suppose if the same roller is pulling, shall I draw here? Is it able to see? Is it visible?
Yes, sir.
If I draw? Is
Yes,
it okay?
yes, sir.
Here?
Yes, sir.
Yeah, let me draw here. Now let me pull the roller. This is N. And let me pull the roller like this. With an angle theta. See, I am pulling the roller like this. Handle. This is pushing. Now pulling. See the arrow mark direction? Resolve the force into components. What is this component?
F cos theta.
And tell me in which side F sin theta will act?
Upward, sir.
F sin theta. F sin theta. Okay? And see, from this diagram, what is Fr? Fr is equal to mu n. Fr is equal to mu. What is n?
F sin theta.
N plus F sin theta balanced by mg. N plus F sin theta balanced by mg. So N plus F sin theta balanced by mg. That means what is n?
mg
mg minus f sin theta.
T minus f sin theta. So Fr is equals to mu mg minus f sin theta. Let us suppose equation number 2. Identify the two equations. Just I am doing only frictional forces. We can find resultant force also. Resultant force is again same, f cos theta minus Fr. But Fr value is different. Tell me, in which case the frictional force is maximum and frictional force is minimum?
Sir, first case maximum, second
If
case
it is pushing, then frictional force is maximum.
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 Pulling, frictional force is minimum.
Minimum.
Then minimum frictional force is sufficient or maximum frictional force is good?
Minimum.
Minimum.
Minimum frictional force.
Is easy.
Minimum.
Which one is easy? If the frictional force is less, we can pull easily. If the frictional force is more, we cannot pull. Okay. So
Cannot
tell
pull.
me whether the pulling is easy or pushing is easy. In case of pulling,
Pulling, sir, pulling is easy.
in case of pulling, frictional force is less. In case of pushing, frictional force is more. Frictional force is more. Then we can pull the lawn roller easily than pushing. So pulling is easy or pushing is easy?
Pulling.
Yeah, pulling is easier than pushing. So at the end you write a word from equations 1 and 2. So the roller can be pulled easily than pushing. The roller can be pulled easily than pushing. Why? Because in case of pulling, frictional force is less. In case of pushing, frictional force is more. Okay, general things. We can find resultant force. Leave the resultant force. Next I will continue resultant force and all. By using resultant force also, we can decide that pulling is easier than pushing. So roller can be pulled easy than pushing. Right, everything. So we can pull the roller easily than pushing. Now see some more conditions. What about diagram and formula? Everything is over, covered, written everything, everyone?
Yes, sir.
Yeah. Okay, we'll wait. You carry on. From equations 1 and 2, we can decide already. So the roller can be pulled easy than push. So lawn roller can easily pull than push. Like that. Okay, you can write in your own way words. Now let me apply some inclined force. How much inclined force we need to apply on a body so that the body ready to move. Let us find some different cases in the next session, in continuation now. First you complete this. I'm going to find what is the minimum force is required so that the body ready to move on a horizontal surface. Okay, minimum pushing force is required. And what is the minimum pulling force is required so that the body will ready to move on a horizontal surface. Means I'm going to consider a block that I'm going to place it on surface so that I want to apply some force. For a particular force, the body ready to move. Let us see for what force the body ready to move. You write it. That's why I'm using some words now. Write these things. Let me continue. Yes, later. So write down the heading. Inclined pushing force. Applying an inclined pushing force. Write down the heading. Applying an inclined pushing force. Otherwise, the minimum force required for the body, the minimum force required for the body ready to move, the minimum force required for the body ready to move.
Sir, for this part, we have to write closing sentence.
Which one?
For this one.
You can write resultant force, no problem.
Means FR equation 1 is greater.
Yeah, equation 1 is greater than equation 2. Only the way you try to understand means whether pulling is easy or pushing is easy. That thing you observe it. Okay, no need of all these formulas and all those things. Whether the roller is pulling is easy or pushing is easy. That point you catch it. Now, applying an inclined pushing force. Let us consider a block which is placed on horizontal surface. Then weight of the block acts vertically downwards and normal reaction force perpendicular to the contact surface. Let me apply a pushing force like this. Okay, it is pushed with an angle of inclination theta. With an angle of inclination theta. Now I applied a pushing force. Means how much the minimum pushing force is needed so that this block are ready to move. Okay, it's not moving. How much the minimum force you have to apply? How much the minimum force you have to apply on a body so that that body has to ready to move. Ready to move. It's not moving. If it is moving, then kinetic friction will comes into play. Now, so resolve the components like a previous, like a roller. And this is theta. If this is theta, this is also theta. Same theta, theta. So same value. And this is f. What is this component? F cos theta. What is downside component? F sin theta. Same like a roller. Same like a roller. Right? As the body ready to move, what type of force will act backside?
Frictional force.
What type
FL.
Limiting friction.
Yeah, FL. If it is in motion, FK. Now it's ready to move. FL. For suppose if F cos theta is less than FL, is the body will move? If F cos
No, sir.
theta less than
No,
F
sir.
cos theta is less than FL, is the body will move? The body
No,
will
sir.
be static on a floor. The body will be static on a floor. So this is the condition for a body which is to be static on a floor. For suppose if F cos theta equivalent to FL, if F cos theta equivalent to FL, then what happened now? Then the body, tell me.
Is ready to move.
Yeah, very good. Then the body ready to move. Ready to move. So our target is to find out how much this minimum force we have to apply. Okay. So F cos theta is equal to FL. F cos theta is equal to FL. F cos theta, what is FL? Mu n.
Limiting friction.
Yeah, mu n. F cos theta, mu, what is n from the given diagram? Mg plus
F sin theta.
F sin theta. Now see small extension. F cos theta is mu mg plus mu f sin theta. Simple mathematics I am doing now. Got it? Can I take this f value left?
Yes, sir.
Yeah. Left side is if I take f common, cos theta minus mu sin theta because mu f sin theta.
There we can take blue common.
No, already mu I multiplied. Okay. Because I want to get f value, which is equivalent to what I am getting?
Mu mg.
Mu mg. Then what is the force? Shall I write this side? What is f I am getting now?
Mu mg divided by
Mu mg divided by
cos theta.
cos theta minus mu
Mu
sin.
sin theta.
This is the minimum force required to push the body so that the body ready to move. Now we can extend this formula also. Mu mg by cos theta minus mu sin theta, we can extend into some other formula. What is mu actually? Mu we know tan pi. Remember?
Yes, sir.
Yes, sir. Tan phi.
Mu we can write as tan pi. Pi nothing but angle of friction. Remember? Mu as a tan pi.
Yes, sir.
Mu mg cos theta. This is the tan pi. Tan pi is angle of friction. Sin theta. F is equal to mu mg cos theta. This can be written as sin pi by cos pi sin theta. Are you able to see the equations correctly?
Yes, sir.
Is it visible? Shall I write big? Is this font size is
Visible,
okay?
sir.
Visible.
Okay. Shall I increase size?
No
It's
problem.
visible, sir.
Okay.
Visible.
Then take LCM. Take this cos pi to the numerator and multiply here. Mu mg cos pi cos theta. So cos theta cos pi minus sin theta.
Yes, sir. Sin theta cos pi.
No, already it's cos pi. No, sin theta sin pi.
In
LCM, yes, sir.
LCM I am doing okay.
Yes, sir.
Is this equation correct?
yes, sir. Yes, sir.
Cos pi here and take this cos pi to the numerator. Tell me the equation down here. What is the equation now? F is equal to mu mg cos pi. This is like what? Cos a minus b. See, I am getting one more good equation now. I got the minimum force is mu
Sir, what
mg
about sin theta sin pi, sir?
sin theta sin pi. That's
Cos A
what.
plus B.
Sin theta sin pi.
Cos A minus
Cos a cos b sin a sin b. What is the formula?
Cos A plus B.
How cos a plus b? What is the cos a minus b formula? Tell me, is it correct or not?
Sir, it's cos a plus b, sir.
Cos A plus B.
Cos a plus b.
Cos a plus b, sir.
Sir, there only cos theta minus cos theta plus B.
Cos a plus cos b. Okay, okay. Yeah, we done. For suppose if angle of friction is 0, what is the answer? If pi is 0, what is the answer? Mu mg cos 0 is 1 by cos theta. For suppose if theta 0 or pi is 0, if you know any one value, if you know any one of this value, if theta is 0, let us suppose, tell me, what is the answer? If theta 0, means you are applying force along the floor. If theta 0, what is your answer? Mu mg cos pi by cos 0 plus pi. Nothing but cos pi cancelled. What is the answer? F is equal to mu mg. So you need that much of force so that the body ready to move. Okay. So the minimum force is possible when theta is equals to 0. Substitute theta is equal to 0 for the minimum force. If theta is equal to 0, then what is F? Will you get mu mg? Check the condition. Why it is mu mg? Are you following, students?
So it is perpendicular to the
If the body, if the force is applied in this direction, how much the minimum force required to move the body, to ready to move the body? How much the force is needed? How much it is
Mu
needed?
mg.
Yeah, mu mg. See, substitute theta as 0, cos 0 plus pi, cos pi, cos pi. Cancel. What is remaining? Mu mg. Will you try the same concept for other thing? Means you try to pull the body so that how much the minimum pulling force is needed so that the body ready to move. Will you try the next concept? What about this one? Is it over?
Yes.
Okay, let me try how much the pulling force is needed so that the body ready to move. Okay, you take this one. I'll continue applying an inclined pulling force. Pulling force, not pushing, pulling force. Yeah. So I'll do the diagram, you try to extend it. See, this is the block which is placed on horizontal surface, having coefficient of friction mu, mg, and you try to apply the pulling force in this manner. Like a lawn roller. What is this? Theta. What is this component? Same. F cos
F
theta.
cos theta, F sin
F
theta.
cos theta. And no doubt this is ready to move means FL. Will you continue the steps? If F cos theta is less than FL, the body will be static. If F cos theta is equivalent to FL, then body ready to move. Please extend the steps. Use some basic mathematics. Try this, everyone. If F cos theta is equivalent to FL, then the body ready to slide. You try this, get the minimum force required to pull the body so that the body ready to move. Minimum force.
Sir, is it mu mg by cos theta plus mu sin theta?
Yeah, I think. Maybe correct. Good. Let me verify. Correct, I think. Yeah. Speed up the equations, everyone. So, for the body ready to slide, what I have to write? F cos theta balanced by what? FL. What is
FL.
FL? What is FL?
Mu
Tell
n.
me.
Mu n.
Tell mu n. Okay. Then write the steps along with me now, everyone. Speed up the steps. Don't waste much time. You continue steps along with me. F cos theta. Mu. What is n actually? N is n plus f sin theta equivalent to. See. N plus f sin theta going to be balanced by mg. Then n which is equivalent to mg minus
mg minus f sin theta.
put this value here. Mg minus f sin theta. Take this value left. F cos theta. I'm writing so many steps for understanding point of view. You extend the steps. Take this f left side, mu f sin theta left side. Take f common, cos theta plus mu sin theta, which is equivalent to what? Vmg. Anyone got this equation? Please respond. Anyone?
Yes, sir.
Yes, sir.
Cos theta
Yes,
plus.
sir.
Got this one? Yeah, very good. If you want, you extend the steps also. Means how to extend the steps? Tell me. Shall we write mu as a tan pi?
Sir, in previous equation, if you are substituting tan phi in denominator, we should substitute in numerator also.
Your wish. No, there are varieties. Okay. Yeah. Substitute.
Sir, writing till this only, it's easy, no, sir, to solve the problems.
Yeah, it is enough actually. It is enough. If no, sometimes in conceptual questions, in entrances, they may not give this as a final option. Then what you are going to do at that time? Of course,
Substitute tan pi.
yeah, means you have to extend it. Based on the given options, we need to change our calculations. Okay, because of course this is the final answer completed. But this option is not given in the given question now. Then you can go for the next option.
We'll
Means,
get,
yeah.
sir, we'll get f is equal to mu mg by cos of phi minus this one
Very
theta.
good. Yeah, that's it. Correct. Theta minus pi, pi minus theta. That's not a problem. Very good. So let me extend. So f is equals to, okay, extend like this, mu mg cos theta plus this is a sin pi by cos pi sin theta. Then you will get f is equal to mu mg. If you want, we will write here also, no problem. Mu mg cos pi by cos theta cos pi sin theta sin pi. Got this? That is equal to mu mg cos pi by cos of. Got this answer? See, in one of the paper they given this option. You remember this formula, but they given this option. Then that's why you try to extend each and every formula. Extension will help a lot. You no need to by heart. Feel concepts correctly. Then we can solve so many variety of questions. Because problems are so many. We can't count the problems. And concepts also so many. If you are thorough the concepts, definitely we can solve any type of problems. Here you feel it. What we are finding actually? What we are finding? We are finding the minimum force required for the body so that the body ready to move. It's not moving. If it moves, again the conditions are different. Ready to move is this condition. And theta minus pi. If theta is equals to pi, if theta and pi, theta is the angle of inclination, pi is the angle of friction. Okay, if theta is equivalent to pi, we can write. If theta is pi, then cos of pi minus theta is equal to what? 0. If theta is equal to pi,
0.
Okay, you want to get the minimum value. Okay, for the minimum value, see, I want to get f minimum. This should be minimum when this is maximum. Numerator by denominator. If this is maximum,
Anything by 0 will become.
how it is 0? Cos 0 is 1. Got my idea. Here I want to get f minimum. My target is to get f minimum. When this is minimum, if this value is maximum, then I am going to get f as a minimum.
Yes, sir.
Clear? I want to get minimum force. When this is minimum, if this denominator is maximum, if this is maximum, when this is maximum, cos 0 is maximum, cos 90 is maximum.
Cos 0 is maximum.
Cos
0.
0 is maximum, cos 90 is maximum. 0.
Cos 0 is maximum.
Yeah, when 0 is possible, that way you
Cos
think.
90.
I am expecting cos 0. Okay, right. So when 0
When
is
the
possible,
angles are equal.
That's it. That's what I'm expecting. Don't worry. Yeah, when if theta is equal to pi, then cos of theta minus pi is equal to 0. Cos 0, which is equivalent to
1.
maximum. Substitute other value. Will you get more than 1? Cos 30 decreases. Okay. So what is the minimum force now? F minimum, which is equivalent to mu mg cos pi. If you want to substitute this mu as a sin pi by cos pi cancelled. You will get one more step. Tell me. Mg sin pi.
Yes, sir.
If that is your interest. See, F minimum is sin pi by cos pi mg cos pi cancelled mg sin pi. So this is F minimum. Condition for minimum force. If you want one more step also, you can extend it. Why? Because we know tan pi is equal to 1 by mu. Sorry, what is tan pi? Mu. Tan pi is mu. So mu 1. What is this value? Remember this one. Tan pi is mu. Remember?
Yes, sir.
Yes,
Tan
sir.
pi is mu. So shall I write? What is tan pi from here? Mu by 1. Nothing but mu.
Yes, sir.
Slowly extending now formulas. Is it correct?
Yes, sir.
Respond from online, anyone?
Correct, sir. Correct.
Correct. Then what is sin pi from this diagram? Sin pi from this diagram.
Mu by
Mu into
1.
In one of the paper they given that option. You remember this. See, they given mu mg by root of mu square plus 1. For suppose they given mu value. They given m value. They ask you to find the minimum force. We can, if we remember this formula, directly we can find. See, without angles, we are going to get the minimum force. Is it okay? So keep all these different forms. If theta pi is given, this is sufficient. If theta pi mu is given, we can use this. So this formula is helpful when mu theta is given. When mu theta is given, we can use this. This is possible. Tell me, what are the given conditions? When mass and
mu are given.
that's it.
Mu are given.
Yeah, when mass and mu are given, you can go for the final formula. If theta is given, you can use this. If pi is given, everywhere they have to give mu value. Then only we can find minimum force. See, this is the case when. Tell me, what are the conditions are given for this one?
Mu and phi and
Mu and
phi.
Pi and m. Mass also important. Mu, m, pi as given. Okay. Let us try one question. I think you are confusing. Let me give one problem. Shall I give one problem? Or otherwise, shall I
Yes,
go for
sir.
next
Yes.
concept? Shall I give problem or shall I go for next concept?
Problem, sir.
Problem, sir.
Problem, sir.
What you are expecting? Okay, done. Let me give. And see, these are nothing easy concepts only. Next, some good concepts will come. Block on block concept. I want to place a block on a truck, back side of the truck. So some good concepts will come in the next sessions, not now. Find minimum force as shown in figure. Find minimum force as shown in figure. Do it fast. Minimum force as shown in figure. What I given? Theta, mu, m, all are given. Then easy. I mentioned theta. This is theta. Mass is given. Mu value given.
So what is the mass, sir? It's not visible.
Yeah, tell me.
So what is the mass, sir?
2 kg. 2 kg.
Okay, sir.
Yeah, 2 kg. Mass is 2 kg. Yeah. See the next concept. Let us discuss the sliding of a chain. Ready to slide actually. Sliding of a chain on a table. Or ready to slide. Ready to slide only we are discussing now, right now. Yeah, got this answer anyone? Can anyone give the answer? F value? Something you are getting root 3 down, something, huh? Complicated numbers you are getting 2 plus root 3, 2 by root 3, something you are getting?
Sir, 20 by root 3 plus
Yeah.
2.
Done. Carry on. Okay, you can use the first formula, mu mg by something formula is there, na? What is the formula? I forgot the formula. Cos theta minus mu sin theta. No, use the first formula, you will get the answer.
Mu by cos theta plus mu.
Cos theta plus mu sin theta. Okay, carry on. And whatever the numbers you got, that is the final answer. No need to worry. Okay. Now let us go for one more concept, sliding of a chain on a table. Leave the space for calculations. You try at home. Let me continue the next one. Sliding or ready to slide. Okay, it's not exactly sliding, ready to slide. See the event like this. Yeah, see this condition. Shall I go for a concept? Speed up. Plus time is moving now. Sliding of a chain on a table. Sliding of a chain on a table. It's not exactly sliding, it's ready to slide actually. Okay, the heading you write like this, no problem. Shall I continue? Shall I start?
So,
Respond anyone?
Yes, sir.
Yeah. See
Yes,
once
sir.
here, let us suppose, let me consider capital L is the total length of the chain. What is capital L? Total length of the chain. And small l is the length of the hanging part. Small l is the length of hanging part. Okay. For a particular length, this red chain is ready to slide or not. If more part is hanging, the chain will slide. For a particular amount of this length, the chain on a table will ready to slide. If this is increases, for a particular amount of this small l, this body will ready to slide. If it is more, what happen now? If this is more than half, then chain will move and falls like a freely falling body. Chain falls like a freely falling body. We need to think about the energy concept that will come in the next chapter. Same concept will come in the next chapter, but here our intention is to ready to move. It's not moving. If it is moving, again some work I need to explain. Right now we don't know the meaning of work. Forget it. Okay. So m is the mass of the chain, weight of the chain. See, what is the normal reaction? Normal reaction is upward.
sir,
Yeah.
chain is that.
Yeah. That's what. Normal reaction somewhere, some point we can take. Okay, from the point. N is balanced by how much? See, this L is L nothing but let us suppose 1 by nth part of total length. What is L? How much part is hanging?
1 by n part of it.
1 by nth part of capital L. Are you following? What is small l? If it is half part, what is n value?
1 by 2.
1 by 2.
1 by 2.
Half part, 1 by 2, L by 2. Now 1 by nth, we don't know how much it is exactly. 1 by nth. If total mass is m, okay, total mass is m, how much the mass of this part?
1 by n.
1
Weight
by
of
m.
this part. Weight of this part is 1 by nth of mg. Are you following? Why it is 1 by nth of mg?
Yes, sir, because it's 1 by n part of total.
Correct? And tell me what is this one? This is mg minus 1 by nth of mg. Are you following why I am writing this one?
Yes, sir.
Is it correct? If it is full part, 0. Half part, mg minus mg by 2. Are you following this step? What is n? What is n? Are you
Normal.
following? N is correct or not? As the chain ready to move, chain ready to slide, we can write frictional force is balanced by limiting frictional force balanced by mu n. Frictional force is nothing but what? There will be a limiting friction here.
Yes, sir.
Okay, limiting friction. That is balanced by, this is balanced by force, this force.
Yes.
Frictional force which is equivalent to 1 by n of what? mg. This Fn, FL is balanced by weight of the body.
By
What
n
is
of
the weight
mg.
of the hanging part?
1 by n.
1 by n into
mg.
mg. Is it okay?
Yes, sir.
What is FL?
Mu n.
Mu. What is n? Are you following
mg
steps?
min.
1 by n mg. Shall I strike off this mg term? Following
Yes, sir, we can take it.
Yes, sir.
mu n minus 1 by n, which is equivalent to what is mu? Is it correct? Say I am getting one link, one relation. Mu is equal to 1 minus 1 by
1 by n minus 1.
1 by n minus 1. I see this mu nothing but shall I write mu s or mu l? Mu s Otherwise, mu L. Tell me. You
Mu
want
L, sir. Mu L.
Mu L, sir.
Okay, no problem. Mu L, you write it. No problem. Mu L. Shall I extend this step some more? Because option is not given this one. Let us suppose. Shall I extend
Yes.
this formula?
Yes, sir.
Mu L is equal to 1. If N is given, we can find mu L value. If half part is hanging, what is mu? If half part is hanging,
1/2.
1/2, sir.
yeah, 1/2. That's it. Very good. Okay. Now let me extend this formula. Up to here is covered already. Formula is enough actually. But in the given option, this formula is not there in a conceptual question. Let us extend it. So n minus 1 is equal to what? 1 by mu L. Got it? N is equals to 1 by mu L plus 1. N is equals to mu L plus 1 by mu L. One more relation between mu L and N. They are given this option. Relation between N and mu L. N is the number. And see from the diagram, what is small l actually? Small l is equals to 1 by n of capital L. 1 by n of capital L.
Capital L.
What is n actually? N. N is capital L by. What is n? Take, you know, L is equal to 1 by L. What is n?
1 by
Capital L by small l, sir.
L by L.
Capital L by small l. We can write it as mu L plus 1 by mu L. Small l by capital L, we can write it as mu L by mu L.
Mu L plus 1.
This small l by capital L, we can call it as maximum fractional length when chain ready to slide. So keep the formula. What is the last one? Maximum fractional length of the chain when the chain ready to slide. Maximum fractional length. Sometimes they will ask to find maximum. What maximum fractional length of the chain is hanging? They will ask like that by giving a mu value. If mu is given something 0.5, 0.5 by 1.5, you will get some number. You feel this concept correctly and try to apply this concept for problems. Otherwise, no use of solving all these concepts. Because next also beautiful concepts are there. Based on the time and situation, I am going to cover all varieties. Okay? But what your target is, you have to practice these concepts number of times, apply these formulas, and solve problems from any type of book. Okay? Shall I stop?
Yes, sir.
Okay,
Yes,
sir.
sir.
Okay, practice this one carefully. Okay, because I done a little fast. No problem. You practice it because the steps you will understand. Once you practice the steps twice, definitely you understand everything. Okay, thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.